Every dollar of fintech revenue and every AML control now runs through your KYC architecture. When traffic spikes, vendors stall, or regulators call, will your identity platform bend or break? In this course, you'll learn how to design systems that stay fast, compliant, and provably trustworthy under real-world pressure. In most real-world onboarding systems, the weakest link is synchronous calls to external KYC and AML vendors. Everything looks fine at normal load, but once traffic becomes bursty, you quickly hit vendor rate limits or capacity caps. After that, new requests just pile up, user sessions block, and timeouts start to cascade through your stack. A small spike can turn into a full pipeline outage. That's why high-volume identity systems must treat vendor calls as a constrained, failure-prone resource. To avoid that, the key architectural shift is moving vendor calls off the critical user path. If every verification is synchronous, your web tier is held hostage by external latency, vendor outages, and rate limits. You see blocked UIs, exhausted resources, and cascading failures during traffic spikes. When you decouple, the web server simply accepts the request, commits intent, and hands work to a queue. Async workers talk to vendors, apply business rules, and update state. This pattern preserves instant UX, protects your core services, and gives you predictable, scalable load. When a user uploads an ID document, you don't want the gateway calling every downstream service directly. Instead, it publishes an event to a queue or event bus. That gives you three big benefits. First, you absorb load. Spikes in uploads are smoothed into a steady stream to your KYC vendors. Second, you control concurrency and rate limit expensive checks, instead of overwhelming external APIs. Third, with idempotent consumers, retries and duplicate events won't corrupt KYC state or double charge vendors. Now think of each KYC application as a living case with a central record and a finite set of states: pending, in progress, escalated, rejected, or verified. Microservices don't call each other in long, fragile chains. They emit and react to events. A sanctions clear event can move the case toward verification. A selfie mismatch event can trigger rejection or escalation. A workflow engine such as Temporal or Camunda owns the state machine, handles timeouts, retries, and branching logic, and keeps the overall case consistent end-to-end. Strategic deferral is about protecting the user experience while still doing thorough KYC and AML. Keep only the essential steps in the interactive path. Ingest the data, run OCR, perform an initial risk check, and decide whether the user can proceed. Push everything else into background jobs. Address verification, periodic PayP, and sanctions rescreening, and bulk reprocessing when rules change. A resilient job scheduler with retries and backoff handles those tasks so heavy or flaky checks never block onboarding or crush your core services. Even with this architecture, external vendors and registries will fail. The resilience triad is how you stop their failure from becoming yours. Timeouts define how long you're willing to wait before cutting the cord. You tune them differently for user-facing calls versus background jobs. Retries give dependencies a second chance, but only with exponential backoff and jitter, so you don't create a retry storm. Circuit breakers step in when things are really broken, opening the circuit after repeated errors so you protect your own resources and user experience. Circuit breakers specifically shield your KYC platform from unhealthy vendors and prevent cascading failures. In the healthy state, calls flow normally, but you constantly watch latency and error rates. Once failures cross a threshold, the breaker opens. You immediately stop calling that vendor, conserving threads, connections, and downstream capacity. After a cooldown, the breaker moves to half open and lets a small number of requests through. If they succeed, you close the circuit. If they fail, you reopen it and continue to degrade gracefully instead of crashing. To route failures intelligently, think along two dimensions: how transient they are and how much human judgment they need. For transient, low-risk issues like network blips, you want the platform to self-heal with retries. When the problem is more persistent, like a vendor outage, automated controls should trip. Circuit breakers, queue backlogs, maybe partial degradation. For soft risk signals, cascade to a secondary vendor. For hard mismatches or fraud flags, stop automation and route straight to manual review. All of this relies on deliberate vendor redundancy and clear routing rules. Graceful degradation turns compliance delays into risk-controlled tiers instead of hard blocks. Think in 3 stages. First, as soon as an account is created, you let users log in and explore, but no money moves while background KYC runs. Next, when automated checks pass, you enable a partial KYC state, low limits, a narrow feature set, and manual review still pending. Finally, only after all checks clear do you unlock full access and higher limits, aligned with your jurisdiction's risk appetite. To operate a serious KYC platform, you need a control room view of system health. Start with clear SLAs and SLOs. For example, what percentage of checks must finish within 5 minutes, and what you promise externally versus target internally. Then track latency distributions, especially P95 and P99, not just the median. Those tails reveal the pain your customers actually feel. Also, monitor business logic, auto-approval versus manual review rates. Emit structured logs, trace user journeys end-to-end, and alert on symptoms before they become outages. To prove resilience, you don't just hope the KYC stack survives bad days, you manufacture bad days. First, drive synthetic traffic through your flows until they're well past realistic peak. That exposes where capacity and rate limits truly are. Then practice chaos. Inject latency into vendor calls, drop responses, stall queues, and watch how the system behaves. You're validating 2 things: whether your SLOs still hold, and when they don't, whether alerts and runbooks get you back to a healthy state fast enough. Finally, let's see how everything comes together in a production-grade KYC platform. Client apps talk to a thin API gateway, which pushes events onto an event bus. From there, specialized services take over. An orchestrator drives the flow, document validation handles evidence, and the risk engine scores the case. Each service is an idempotent consumer of events and persists only case state, not workflow state. External vendors sit behind circuit breakers, so failures degrade gracefully rather than cascade. An observability layer watches all of this in real time, giving you end-to-end visibility and strong operational control over your KYC and AML posture.